In this video, we're going to take a look at simplifying radical expressions. This includes square roots, cube roots, and nth roots, or roots to any degree or any index here. So let's check it out. Let's start with square roots, which we should be familiar with. Square root means what number multiplied by itself gives us this number inside the radical symbol. This is called our radical symbol. This is called our radicand. And so to square root this, a good way to go is to rewrite it as a squared expression. So this is the square root, and 64x squared is the same as 8x to the second power. Remember, our power rules say this exponent affects both of these, the 8 and the x. So this is going to be 8x, because the square root is the opposite of squaring, so it cancels it out. However, when you put a negative number into the original expression and square it, it becomes positive. And here we're taking the principal square root because it's a positive out here. So you're going to end up with a positive number. But this expression can come out negative if you put a negative number in for x. So we've got to ensure that this comes out to be positive, so we have to put some absolute values around it. And so our solution, our simplified expression, is the square root of, the absolute value of 8x. All right, how about this guy? Same idea. Well, we think, what can we square to get 100? And it is 10. What can we square to get x to the 6th? And that is x to the 3rd. Because our power rules say these powers multiply, giving us x to the 6th. And so when we square root this, we get 10x cubed. And again, we need some absolute values around that. All right. And this one, we have a quadratic expression inside. So what we need to do is we need to factor this first. And if we remember, we are looking for two numbers that multiply to this, or actually the square root of this. And the square root of 9x squared is 3x. And the square root of 4 is 2. And since this is a minus 12x inside here, we're going to need a minus. And the squared, and you can multiply this out to see if it really gives you this, to check, and it does, because it's a squared trinomial. So we have 3x minus 2 because the square root cancels out the square. All right, there you have it. One more little example to make note of. If we have something like x to the 8th, well, that is the square root of x to the 4th squared, which is x to the 4th. Now in this case, we don't need the absolute values because x to the 4th is always positive. So we don't have to put absolute values around this because it will be positive anyways. Now let's look at some cube roots. A cube root asks the question, what number cubed gives us negative 27? Now we can't take the square root of a negative number, but we can take the cube root of a negative number, because negative 3 cubed is negative 27. And so the cube root cancels out this exponent here. So let's go ahead and we have negative 3. And yes, a cube root can be negative because negative 3 cubed is negative 27. All right. And so along the same line here, let's take the cube root here. And so we ask ourselves, what number cubed is 125? Well, that is 5. 5 to the 3rd power is 125. And so we can rewrite this expression as 5x cubed. Remember, again, the exponent affects both of these. And so this cube root will cancel out this cube. And so we call this 5x. Now, as we saw over here, yes, we can get a negative number when we take a cube root, because negative 3 cubed is negative 27. So we don't need to make absolute values here. The answer is 5x. If x happens to be negative, that's great. Now, same idea here. We want to ask ourselves, what can we cube to get x to the 12th? And that ends up being 4, x to the 4th, because power to power we multiply. Cube root cancels out the cubed, and we get x to the 4th. Again, don't need to worry about absolute values when you're talking about x cubed. Well, let's try a higher index now. So in general, we have what we call nth roots. So here we have a radical. It looks like a square root, but this index here can actually be any number. It can be an even number, positive number, but it's got to be a whole number. Actually, it's got to be greater than 2, so an integer greater than 2. So we end up, if we have n is even, we're going to need absolute values, just like the square root. If n is odd, we don't need the absolute values like our cube root. So the same rules applies. We're going to do the same techniques here. The fourth root is asking what number to the 4th power gives us 81. And we can think through our powers and have some nice neat numbers, and it ends up being 3. 3 to the 4th power. So 3 to the 4th power is 81. 3 times 3 times 3 times 3. And so the answer here is 3. Here we have a 5th root. Well, can we take the 5th root of a negative number? We can. A little side note, you cannot take an even root of a negative number. You can take an odd root of a negative number. Just like with square roots, we can't take the square root of an even number. It's impossible. So, for the 5th root here, we have to ask ourselves, what number to the 5th power is 32? And that is 2. We'll need to make this negative because we have negative 32 up here. So we got negative 2 to the 5th power is going to be negative 32, and we'll have an x. So the root cancels out the power here, and we have negative 2x. Again, it's fine that it's negative because this is an odd index. One more, we have the 8th root, and this one's not too tough. We already have an 8th root, and we already have an 8th power. And so when we take the 8th root of x plus 5 to the 8th, we get x plus 5. However, once again, this will always come out to be positive because it's an even root. The even root, when there's no negative out in front, we're looking for the principal square root, or the 8th root in this case. So that will always be positive. We need to ensure that x plus 5 is positive no matter what x you put in. And so we have to put absolute values around it. So there you have it. So we have different roots, and in general our nth roots. Watch out for those absolute values only when we're dealing with a variable. And we remember that it's okay to have negative numbers inside of an odd root. It's not okay to have negative numbers inside an even root. Well, there you have it. Good luck.